Welcome, everyone. Thank you for joining us for today's keynote presentation titled The Opioid Epidemic in Ohio, a Crime Laboratory Perspective. It's my pleasure to introduce to you our keynote, Douglas E. Rohde. Douglas has been employed by the Lake County Crime Laboratory, Ohio since January 2000 and serves as the Supervisor of Chemistry and Toxicology. He holds a Bachelor's of Science in Chemistry from Gannon University and a Master's of Science in Chemistry Clinical from Cleveland State University. For a complete biography on our speaker, please visit the Biography tab located at the top of your screen. My name is Xavier Gutierrez, and I will be your moderator for today's event. We're delighted to bring you this educational web seminar presented by LabRoots. LabRoots is the leading scientific social networking website and producer of educational virtual events and webinars. Now, before we begin, I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want during the presentation. Simply click on the Ask a Question box located on the far left of your screen and type your questions into the drop-down box. Our speaker will respond to your questions via email following the presentation. And this presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located in the top right corner of the presentation window and follow the process to obtain your credits. Now, without further ado, please join me in welcoming Mr. Douglas Rohde. I will now turn the presentation over to him.
Hello, my name is Douglas Rohde. I'm the Supervisor of Chemistry and Toxicology at the Lake County Crime Laboratory. It's a privilege to present for the LabRoots Clinical Diagnostics virtual event. I am including a conflict of interest statement. I have no conflicts of interest with any commercial or financial relationships. So where is Lake County, Ohio? Lake County is to the east of Cleveland on Lake Erie in the northeast Ohio area. You can see this on the map. We are proximate to Pennsylvania to the east, West Virginia, Kentucky to the south, Indiana and Michigan to the west. Our laboratory is a smaller crime laboratory, and we employ approximately 15 people. In the drug chemistry and toxicology section, I have 3 people employed. My talk today is going to be about the opioid epidemic, and I will be talking about some of the history of how this all started, what exactly are opiates versus opioids, some of the pharmacology involved, and then the trends we're seeing. And then I'm going to finish the presentation with testing items such as immunoanalysis and confirmatory testing. So in 2015, the Washington Post had an article where opiates killed the most people in 2015. And you can see on this map, as the states are shaded darker, it indicates a greater concentration of deaths due to opioids. On the left is the heroin deaths in 2015. On the right, opioid deaths. You can see there was a concentration in the Midwest here with Ohio, West Virginia, and Kentucky. And that trend has remained stable throughout 2019. Vox did an article regarding the opioid epidemic, and it stated it's America's worst drug crisis ever. I've been doing toxicology testing since 1983, so I did live through the cocaine epidemic in the 80s, and then the methamphetamine epidemic, and I agree, this particular epidemic of opioids is far greater in the number of deaths and complications for analysts than anything before. You can see, I'm going to go back a slide. At the end of this article, the last sentence, preliminary data we have from 2016 suggests that the epidemic may have gotten worse since 2015. And indeed, that was true, especially in Ohio. This is from the Centers for Disease Control, and you can see how opioid-related overdose deaths rose nationwide versus what happened in Ohio. There was a precipitous rise from 2015 to 2016. And then this chart, if you take it further out, the rise continues, both nationally and in Ohio. So when did we first start noticing a problem? In 2010, and I'm going to speak predominantly about the Cleveland area and Ohio, but this is true nationally to some extent as well. There are pockets of opioid centers that are worse than others. Obviously, based on the charts that I've showed, the maps, Ohio, West Virginia, Kentucky is a particularly bad hit area. And then in the West, some states haven't even experienced an opioid epidemic at all. So there was an increase starting in 2010 with the number of opioid deaths in the Cleveland area and the surrounding suburbs. 77% in Cleveland proper, and then 176% in the surrounding suburbs. The sale of opioids quadrupled in the last 15 years. And it is interesting to note the United States consumes 80% of the global supply. Healthcare insurance claims followed suit with opioid dependence claims. Those increased 3,000%. And then opioid deaths exceeded 18,000 a year due to heroin. They would interview heroin users, and 90%, greater than 90% of these individuals had stated they had switched to heroin because it was cheaper and easier to obtain than some of the prescription opioids, such as oxycodone. There was a federal act, the Comprehensive Addiction and Recovery Act, signed by President Obama in 2016, which did bring national attention to the problem. And it is drug overdose by far is now the leading cause of accidental death in the United States. So the first exposure, so to speak, of opioids, we've all been, quote, exposed to opioids through a classic movie. And you can see here in The Wizard of Oz, there's a particular scene where Dorothy and crew are trying to get to the Emerald City, and they have to cross a field of poppies, and Dorothy falls asleep. In the movie, the antidote was snow. And if that were true, if that worked, then perhaps we wouldn't have such a problem here in the Cleveland area, especially this time of year. However, as you know, that was just a movie presentation, and the antidote or the recovery for an opioid overdose is Narcan, and we'll be talking about that a little bit later. The opium poppy has been in existence for quite some time. 3200 BC, there's a notation of poppies being grown in the Mesopotamia area. And you can see in the bottom right photo the collection of the sap or milk from the poppy by scoring the poppy pod. And you can see the sap coming out, and then that is collected. So there is some confusion, and it still exists today, over the definitions, opiates versus opioids. And opiates refer only to the alkaloids that are found in the opium poppy, such as morphine, codeine, papaverine, and thebaine. Opioids is an umbrella type term that covers not only the opiates, but the semi-synthetics like heroin, and then the synthetic opioids such as fentanyl. There is a term used and bandied about quite a bit, narcotics, and some people will refer to the opioids as narcotics, but really narcotics is a term covering not only opioids, but drugs of abuse and illicit drugs in general. So what do opioids do? We all know this, especially those of you in the clinical arena. It's designed for relief of pain and severe pain. Is used in preparations for suppression of cough or an antidiarrheal medication. And of course, the epidemic primarily is due to the fact that opioid abuse can cause euphoria or will cause euphoria. You can develop tolerance, and then you can also have dependence on opioids. It goes without saying that the opioid drug is highly addictive. It is not unusual to have drivers, and what I do at the crime lab is predominantly toxicology testing regarding impaired drivers, and also some work for the coroner. And one of the telltale signs of an opioid overdose in a driver or someone found unconscious is pinpoint pupils. This is the sign that law enforcement officers will use and DREs will use to determine whether someone is under the effect of opioids. You will have CNS depression and, of course, respiratory depression and pulmonary edema. Respiratory depression is a telltale sign as well, slowed breathing, agonal breathing. And then eventually, if you have enough of an opioid or several opioids in your system, the respiratory center will cease to function, and that leads to death. The opioid receptors are primarily located in the brain and spinal cord, but they're really spread throughout the body. The effects of opioids depends on the types of receptors which are bound and where the receptors are located in the body. There are 3 primary opioid receptors, and delta, kappa, and mu are those receptors. Many people have heard about the mu receptor, but there are others as well. This slide is a little busy, but I wanted to show which receptor was responsible for which effect of the opioids. You can see that pain relief is linked to several of the receptors, pupil constriction, and the mu receptor is primarily the receptor responsible for the euphoric effect of opioids. If you go down to the bottom of this slide, second to the last sentence, euphoria is a result of the dopamine release, and neurotransmission is the cause of a runner's high. So those of you who are athletic and run, you may have felt the euphoria that you hit after you hit the brick wall, and then you feel better. This is a dopamine release. All opiate receptors, all forms of the opiate receptors can be found in the brain, also the spinal cord and digestive tract. This slide emphasizes the fact that one of the major effects of opioids is to inhibit pain. And the neurotransmitter release is inhibited, and that will also inhibit the conduction of the pain impulse. And here's a picture of that, a neurotransmitter in the synaptic cleft, and how there's a block of the release of the neurotransmitter. There's a part of the brain, and it's called the nucleus accumbens. And this is where your reward system is located, the pleasure center of the brain. And you can have receptor stimulation in the nucleus accumbens, resulting in impulses leaving the nucleus accumbens and activating the reward system. This is the euphoric effect, which is felt. So here we see not only the the relief of pain, but also the activation of the pleasure center, two of the major effects of opioids. The opioid antagonist, which most people are familiar with, is naloxone, commonly known as Narcan. This is a short-acting antidote. The half-life is 1 to 2 hours. When an individual is pulled over or detected on the road and they are suspected to be under the influence of opioids, naloxone is often given. And depending on the response to the naloxone, that will depend on how many doses are administered. When the opioid epidemic started several years ago in the police narratives, I would note that there would be 1 to 2 doses of naloxone given in a heroin overdose. As the potency of the opioids increased, we started seeing fentanyl and some of the fentanyl analogs, the amount of naloxone that was required to block the opioid binding to the receptors increased. And there was a report from the Highway Patrol, and this was probably 2 years ago, that they had one traffic stop where they administered 16 to 18 doses of naloxone to a driver. Now, since that time, that record may have been broken because we have consistently and continually seen more potent opioids, one of which I will be talking about later in this presentation. Now, Naloxone is another opioid antagonist. It's longer acting, the half-life of 11 hours, and it's designed to guard against placing a person into opioid withdrawal. So in the case of an emergency response, naloxone is given repeatedly until the individual is transported to a hospital, a medical facility, where it can be given either IV or continued to be administered until the amount of opioid that's present in a person's system is diminished. There is tolerance to opioids, and this is also part of the epidemic that we're seeing. And it's amazing. It's an amazing thing. I had never believed it possible that the human body could be so tolerant to opioids. And we've seen in extreme cases, the most potent opioid we've encountered is carfentanil. And we have noted that people have built a tolerance to this drug. I'll be talking about carfentanil a little bit later, but it is designed as a large animal tranquilizer, certainly not for human consumption. Yet people are taking it, and they're taking it along with other opioids. So there is a great deal of tolerance that can be built up to opioids. One of the dangers of this is that if a person goes into treatment or jail, and then they are absent opioids for a period of a week or two or longer, and they go back out on the streets or back home and resume their opioid use, there is a tendency for these individuals to return to the same dose that they had used prior to their incarceration or their treatment. And you will lose your opioid tolerance over time. And that is a cause of many opioid overdoses and deaths. Simply people who have lost the tolerance and don't know that they've lost it, and they return to the dose that they were used to. One thing I wanted to emphasize in this slide as well, regardless of the tolerance that will be developed with individuals, you will still have pinpoint pupils. And that's still an outward sign where clinicians or law enforcement will receive a hint that someone is under the influence of opioids. So I'm going to go through some of the opioids that we know about, and I'm going to also transition into some of the new fentanyl analogs you may not have heard of yet. So it all started with morphine, and morphine is nothing new. This was extracted over 200 years ago. Morphine was named after Morpheus, the god of dreams. It's interesting to note this is the prototypical opioid on which potency is measured. So whenever a new analog, fentanyl analog or opioid emerges, the potency will be compared to morphine. After morphine, then there was a development of heroin. And this was synthesized in 1874. If you are a history buff, you know that a few years before that was a major event in our country, the Civil War. And what had happened was the veterans were suffering with a great deal of pain, because back then medical care obviously wasn't like it was now. There were many amputations. And the physicians then noticed that these veterans were becoming addicted to morphine. So there was an attempt to chemically alter the morphine to make it less addictive. And through acetylation, they created heroin. And heroin was designed to be a safer alternative to morphine. It is a Schedule I drug. And, in the United States, we have 5 schedules. Schedule I being a drug with little to no medical benefit and high addictive potential. And there are a handful of drugs in this schedule, heroin being one of them. There are 2 forms, the salt form, the hydrochloride salt form, and the classical heroin, which has been in existence for some time, is usually a beige tan color, but it can be white. And then there's a freebase form where you would have black tar heroin. Interestingly enough, the black tar heroin, at least in Lake County in Ohio, disappeared for some time, but lately we've seen it return in some of the evidence submissions we've had. And that requires heating to liquefy it so that you can inject it through IV injection or vaporization. Another interesting property of heroin is that it is a very fast metabolizer. The half-life of heroin is 3 to 6 minutes, which is extremely rapid for any drug. And you will not detect heroin in a toxicology screen or confirmation unless the sample is drawn within that small time frame. But you will oftentimes see 6-monoacetylmorphine or 6-AM. This is a marker which is definitive for heroin, and it is screened for oftentimes in the urine, because it will be present for a longer amount of time. Here's a little bit of organic chemistry for those who are chemistry majors. And you can see heroin at the top with the acetyl groups to either side. And the first metabolite. You'll see just the one acetyl group instead of two. One is removed, and then the second one is removed, and you go back to morphine. I describe this when I go to court in front of juries, that heroin is like a Mickey Mouse hat, and everyone can envision that, and that the ears are the acetyl groups. And if you break off one ear, you have a Mickey Mouse hat with one ear, that is 6 monoacetylmorphine. And then if you subsequently break off the other ear and just have the cap without ears, that is morphine. Oxycodone is a semi-synthetic opioid, and that was synthesized over 100 years ago. Nothing new. It has been around, and it is a Schedule II drug, meaning there is obviously medicinal use for this drug. It was created, once again, as an alternative to morphine, and you can obtain this either as an immediate release or a controlled release, which is OxyContin. And the oxymorphone metabolite was discovered to be about 10 times more potent than the parent oxycodone. There was a reformulation about a decade ago, which precipitated the abuse of oxymorphone or Opana. This was a particularly, West Virginia was particularly hard hit by Opana in one particular town. There were, I forget how the percentage of the population of this town was addicted to oxymorphone. And then we come to fentanyl, which is getting all the attention now, and rightfully so. It's 80 to 100 times more potent than morphine. And there are several derivatives of fentanyl. You can see the last analog there is carfentanil, a large animal tranquilizer. Fentanyl, once again, has been around for a while. And I remember when I worked at the Cleveland Clinic Foundation, there were fentanyl patches and fentanyl patch abuse. And there was not only abuse from patients, but also from some of the staff as well, unfortunately. The abuse of transdermal patches was a problem for quite some time. I'm not sure anymore if that's a common occurrence or not. But working not only in a clinical laboratory, but also a forensic laboratory, and at one time I worked for a coroner, there were occasions where people would have several fentanyl patches all over their body. It was quite a sight to see. Fentanyl, of course, is used quite a bit medicinally, either in hospice care, surgery, all for pain relief. The new form is essentially a powder, and it is purchased illicitly, distributed illicitly. It has the appearance of other narcotics. And I want to emphasize that with these new forms of opioids, they all look the same. They're all a white powder or tan, or they can be multiple colors as well. We've seen blue, green, just any kind of color. There's no way you can look at a powder, and we do this in the crime lab for our drug identification. There's no way you can tell when you have a white powder whether that is methamphetamine perhaps, or cocaine, or fentanyl analog, some fentanyl analog. You just can't tell by looking at it. And that it requires testing at the molecular level for identification. On the right is a small, the picture on the right shows the small amount that would be considered a lethal dose if it was injected into the body. Just a few grains of fentanyl can be lethal. Here's a slide that shows the impact of fentanyl in Ohio from 2012 to 2015. I used the term skyrocket quite a bit for interviews that I gave about the fentanyl epidemic in our region and in Ohio. You can see how many deaths or overdoses we had in a short amount of time. They just went up so high in such a short amount of time. It was incredible to take note of this and try to track it. And they still, the fentanyl deaths still rose the next year and the next year after that. I wanted to provide some therapeutic, toxic, and lethal levels for comparison. And morphine at the top, your therapeutic is less than or equal to 100 nanograms per ml. Then you drop down to fentanyl and you can see it's 1 to 3 nanograms per ml. And oxycodone, oxymorphone, hydrocodone are in that mix. So the amount of the drug that is needed to achieve the effect of morphine is considerably less. And it's not unusual to have barely enough to even weigh, just have residue in the submitted evidence, which could turn out to be deadly to the individual. So I wanted to talk about one particular opioid that showed up in Ohio in 2016. This was U47700. Now, this is not a fentanyl analog. It's correctly classified as an opioid. And Ohio was very aggressive when this showed up in Ohio, and we had a number of deaths. The legislators in Ohio acted very quickly to schedule this drug to try to mitigate its effect within the state and penalize those who were using it and distributing it. So the first fatality of U47700 was in my county, Lake County. And this is partly why I'm presenting it, because I have firsthand knowledge of this. In January 2016, we had a young man in his 20s who was living with his parents, was found dead on the floor of his bedroom. And although we don't do the high-end toxicology testing that reference labs or postmortem labs will do, we do as much as we can in the crime lab with screening. And then one thing that is particularly unique about my crime lab, because it is small, is that not only do I see the toxicology results, I also supervise the drug chemistry, so I'm able to see what is happening on the streets. And there is a lag time between those opioids that are detected in powders that are confiscated and submitted to the crime lab versus the detection in the toxicology sample. There's approximately 6 months or longer lag time, or there used to be at this point. So the coroner would, when he had a suspect opioid death, would collect all the paraphernalia found at the death scene and submit it to the crime lab, so we could immediately do analysis of the syringe and the powder and let him know what we had found, so he could in turn either compare to the subsequent toxicology results, which takes some time, or inform the toxicology laboratory that this was what was found proximate to the body. This is a picture of the death scene, and on the lower left you can see the body of the young man. Where the blue arrow is pointing is where the drug paraphernalia was found. This is the evidence that was recovered. There was a substantial amount of white powder found in a rolled up $10 bill. I understand in this picture that $10 bill is flattened, but it became flattened in transportation from the crime scene to the laboratory. But at the time the officers recovered it, it was rolled up. And once again, note the appearance of the powder. It is a white powder. This looks somewhat fluffy, for lack of a better term. And looking at it, there's no way any forensic chemist could tell by appearance exactly what that powder is, or if it's one drug or several drugs contained within. The chemical identification, but once again, this is a list of evidence found in the vicinity of the decedent. The white powder, the rolled up $10 bill. There was a paperback book with powder residue, which was the platform the decedent used, we suspect, to use to ingest this powder or snort it. There was a dropper bottle with an unknown liquid, and then an e-cigarette was found. In a crime lab, some of the common tools used for chemical examination are gas chromatography, mass spectrometry, and FTIR, Fourier transform infrared spectroscopy. The e-cigarette, the contents were identified as nicotine, and then everything else contained an unknown substance, meaning that what we had analyzed was never seen in our laboratory before. We had no library entry for the resulting spectra on the GCMS. It was totally unknown to us. So what are the tools in a crime lab that can be used for identification? All crime labs will have an in-house mass spectral library. There are commercial libraries and vendor libraries which can be utilized as well. And then if that doesn't work, you start making phone calls. There's a good network of drug chemists within Ohio. We were all battling this at the same time, and it's common for the drug chemists to call one another to see if this particular drug was seen in a different area of the state. Drug abuse is very regional in our state, we have found, and it holds true with this opioid epidemic as well, meaning that in the northern part of the state, in the Cleveland area, we would see drugs that they weren't seeing in the southern part of the state, which would be Cincinnati, Dayton. And then conversely, they would identify drugs that we hadn't seen yet. There is a group of drug chemists that focus solely on clandestine laboratories, and I sought out their assistance as well. There's a great network of forensic toxicologists in the United States. I have been involved with the forensic toxicology field for some time now, and these scientists are eager to help one another. You just give a phone call or an email, and I did that with several of my colleagues to find out if they had seen this unknown drug. And then beyond the borders of the United States, there's an international group of forensic toxicologists which can be contacted as well. And then as a not necessarily a last resort, but if you have enough time and knowledge, you can look at the spectra for interpretation and then look at and then do structural elucidation. That is time consuming, and oftentimes drug chemists don't have the luxury of time. So they'll use some of these other avenues, as I did. My first indication of what I had was an international toxicology warning system, the Belgian early warning system on drugs of the Scientific Institute of Public Health, reported in February 2016 about a fatality involving a newer opioid, U47700. Remember, my death was kind of in the middle of January of 2016, and this was my first knowledge or indication that there was a new opioid present in the drug stream. And then they listed what type of opioid this was, the potency, and what the action, and much like morphine. And then go back a slide. So this gave me an indication of what it was, but that's not enough information for me to definitively identify when I have an unknown. I need a spectral match to what I have. And that was provided by a colleague in Dallas, Texas, Dr. Spargo, who had published an article in Tox Talk, which is distributed to forensic toxicologists in the United States and beyond. And you can see in the right-hand corner, this was a March-April edition, and this was my first indication of a spectral match to my unknown. So at this point, I had suspected I had U47700. Now, I knew for sure that this is what I had. Interestingly enough, one of my colleagues in Lorain County, which is on the other side of Cleveland, Lake County is on the eastern side of Cleveland, Lorain County is on the western side. They had encountered an unknown drug, which turned out to be U47700 in February. So this drug had hit in Ohio, and it was showing up in the Northeast Ohio area. And each of us was trying to figure out what this was. This particular formulation of the drug wasn't a powder, but it was a clandestine fake oxycodone tablet, which did not contain oxycodone, but contained the U47700. So the toxicology initial report from February indicated the presence of presumptive positive for benzos and cannabinoids by immunoassay, and then a confirmatory result of the marijuana metabolite in blood. Was that enough to explain the death? Was that providing an identification of the unknown powder? No, it wasn't. So by the time I had identified what this powder was, and we had notified the toxicology laboratory in March, we had found out that this laboratory was working on an assay at that moment to identify newer synthetic opioids. And one of those opioids was U47700. So all of this was occurring essentially at the same time in the winter of 2016. So once that toxicology laboratory had worked up and validated their assay, they issued a secondary report which identified the unknown substance in the decedent's blood as U47700, which correlated to my identification of the powder, and it was at a lethal level, 242 nanograms per ml. Coroner ruled the manner of death as accident, and the cause of death as U47700 toxicity. Some of the demographics in the area indicate that, and this was in the Northeast Ohio area, interestingly, the age of the abusers were 27 to 49, gender, mostly male, marital status, married, single, and unknown, race, predominantly white. All of these individuals had a history of past opioid abuse. So they were trying a new opioid. Here's where the legislators in Ohio took action, and our governor at the time, John Kasich, issued an executive order, 2016-01K, dealing with the synthetic opioid known as U4770. He put it into the Schedule I category, and this was on May 3rd, 2016. So the decedent in Lake County died in the middle of January, and 3 months later, or 4 months later, the drug had become scheduled. It was an incredibly fast process to do such a scheduling. This even got the attention of the Wall Street Journal, and they wrote up an article about the U47700 and how Ohio was so aggressive in scheduling this and trying to control it. But even though we felt good about what had happened, we had no idea what was coming next. And we got hit very bad in Ohio, especially once again in the Northeast Ohio area, with a number of unexplained deaths. They all happened in Summit County, that's where Akron is, south of Cleveland. 52 unexplained deaths in 1 month. And I believe in one weekend there were 16 or 18 deaths. Totally baffling to the medical examiner and the forensic toxicologist there. It turned out to be carfentanil. And you have probably no doubt heard of the spread of carfentanil and how potent it really is. And that's what had happened. Carfentanil had hit Ohio. We were unaware. And in order to get a carfentanil standard, and remember, this is a large animal tranquilizer, not really available commercially to any laboratory. We all had to go to our local zoos to get a carfentanil sample to compare to this unknown drug. Here is a potency chart, and carfentanil, you can see in relation to fentanyl how potent it is, and that's arrows pointing to zoo workers tranquilizing a zebra with carfentanil. So it has turned out to be the mother of all fentanyls, and I say so far because there are potentially 1,400 fentanyls or more that have been either designed or synthesized, and some of them have a potency greater than carfentanil. Fortunately, we haven't seen those yet. In the lower box, the paragraph, last line, in 2017 in the United States, there were 451 carfentanil cases. And of those 451 identifications, 83% were in Ohio. So we were hit very hard in this region. This is a submission in one of our agencies in Lake County of 13 grams of carfentanil. It only takes a few grains to cause death. So you can imagine the potential for 13 grams, how many people could die from that amount of carfentanil. But now we're dealing not only with carfentanil, but several other fentanyl analogs. And it's part of the opioid tsunami. the tsunami continues and the opioids and the analogs change, but we're still having to deal with the tsunami on a daily basis. This slide, I apologize, it's small in print, but it is the opioid caseload in my laboratory. The numbers aren't particularly large in comparison to a state lab, but what I want to emphasize is the trend of the particular drugs and then by year. So you can see heroin on the first line is heroin. It really peaked in 2016 and has declined since then. Fentanyl peaked in 2016 and it dipped a little bit and then went up in 2018. The U47700 was present in 2016, 2017, and essentially disappeared for a while. But notice in the difference between 2016 and 2017, how many new fentanyl analogs we had detected, and then between 2017 and 2018. So every year we will have a whole slew of new fentanyl analogs unknown to us, which are present in the submitted evidence that we get. Carfentanil, just of note, it showed up in 2016. It really peaked for us in 2017 and then diminished. But then by the end of last year, it had gone dormant. We didn't have a case for several months. But at the beginning of 2019, carfentanil was back in the drug stream, in the drugs in Lake County and also in all of Ohio. So we're peaking again with carfentanil. I'm going to go through these relatively quickly, but you can see these are examples of submissions to our laboratory. And when we talk about these fentanyl analogs, it's not just one or two that are showing up in drug paraphernalia. It could be as many as 5, 6, 8, sometimes 10. So it's not unusual for us to get pieces of straws, paper folds containing powder, and then it will contain several different analogs and opioids. And you can see, imagine ingesting that amount of fentanyl analogs and trying to figure out the potency of each one and how, in combination with one or the other, how the human body deals with that. And once again, I'm amazed at the tolerance that individuals have to all of these fentanyl analogs. Here's another example. This was a spoon and a needle containing brown liquid, which was blood, of course. And not only did you have carfentanil, but a whole slew of other fentanyl analogs in the syringe. Here's a syringe with a needle, 6, 7 different fentanyl analogs plus heroin. Here's another example. This was a syringe with a needle. Just incredible the amount of fentanyl analogs that can be seen. Interestingly, in this one, you'll notice towards the bottom there's cocaine. Cocaine and methamphetamine have risen up again as drugs of abuse. They were lower for a while, but now they're coming back into vogue, so to speak. And then also clandestine pills, where they purport to be oxycodone, but they contain fentanyl analogs. And the professionalism of these clandestine tablets is amazing. By visualization, by trained drug chemists, we can't tell the difference between pharmaceutically prepared tablets and the clandestine tablets. They look identical. I'm going to go through these relatively quickly. These are reports of fentanyl and fentanyl analogs throughout the United States. This is fentanyl in 2017, and you can see, depending on where you live, how fentanyl is affecting that state. This is carfentanil. Of course, Ohio stands out in each one of these slides. This is acetylfentanyl, acrylfentanyl, fentanyl, 3-methylfentanyl, cyclopropylfentanyl, and then U47700. We tried our best in Ohio to try to diminish it, but we still were, unfortunately, the #1 state that had this drug in it. So I want to finish up by just talking about clinical and forensic laboratory testing. We're all in the same boat here. Analyzing the fentanyl and fentanyl analogs is a real challenge. And when you're having to deal with turnaround time in a clinical laboratory or court time in a forensic laboratory, it's really quite a challenge. And we're both disciplines are facing the same challenge. This picture, by the way, I grabbed off of the Wikipedia entry for hospital laboratories, and I can see it's kind of old based on the computer monitors, but you get an idea. This is a typical screening instrument for a clinical lab. Immunoassays is still the preferred and quickest way to screen for drugs. They've been in existence for a very long time in both clinical and forensic laboratories. But when you're dealing with fentanyl, it's a bit of a problem. There are cross-reactivity problems. And then as these new analogs, which I've listed and shown in the previous slides, become present in the drugs on the street and then subsequently in the patients, the immunoassays probably won't pick them up. Here is a chart of a comparison of commercial kits. There's 9 separate commercial kits for fentanyl immunoassays, and you can see the cross-reactivity. If you have greater than 50%, you have a green good bar, moderate 10 to 50%, 10% low, and then the black part of the bar is not tested. Percent of fentanyl analogs not tested, 59%. Providing references, and these are recent references from last year regarding fentanyl immunoassays. If you are interested in further reading about these and some of the problems, I would recommend getting a hold of these references. Another great source that I utilize quite a bit is the AACC artery, and particularly the toxicology threads. This was one from August and September of this year talking about fentanyl immunoassays, in particular, or specifically the ones that are FDA approved, and the recommendations from a variety of laboratories of what they use, what's good and bad. Now, because I work in a forensic laboratory solely, I have limited contact with clinical labs, although I still keep my toes wet in the clinical realm. And will oftentimes visit the laboratories in the Lake County area and also work with our probation department that are using some of these assays. I would encourage you, if you are a member of AACC, to jump on and look at the artery and the discussions. They're very useful. There's point of care options, and I know some probation departments will use the cups for screening, but I am not particularly impressed with those because I've noted there are a fair amount of false positives with these cups. And always with fentanyl urinalysis screening results, the interpretation must be done with extreme caution, because a negative result does not necessarily mean you have no fentanyl and or a fentanyl analog. You saw the slide where I had how many analogs could be present in one individual syringe, and that means all those analogs will be present in the person as well. You are not necessarily going to catch them in a urinalysis screen. So the bottom line, and many of the contributors to the thread said physicians oftentimes, and rightfully so, treat the patient based on the clinical presentation. Here's a few presentations. So case number 1, 23-year-old found unresponsive in bed, was given naloxone, admitted to the ICU, and then eventually discharged. If you are using a GCMS, which is a high-end type of instrumentation, even in a clinical lab, you potentially could miss the opioids. And here on the left is a GCMS result. On the right is an LC time of flight MS technique, but LC-MS is commonly used as well. And you can see the type of instrumentation lends itself to greater sensitivity in all these drugs that were present that weren't picked up by GCMS. And then here's another presentation. 17-year-old student before class would snorted some powder, was found unresponsive in the car, and a school nurse administered naloxone. Patient adamantly refused using opioids, yet ultimately U47700 was found within that powder. This is my last slide, and I want to provide a little bit of good news here. The overdose deaths dropped last year in Ohio, and then within the article, they noted that overdose deaths decreased across the United States last year in 2018, and that was noted as the first drop in nearly 3 decades. So maybe, just maybe, this tsunami is subsiding, and we can get some relief from the opioid epidemic. It's not going away anytime soon. Our laboratory this year identified, I think, 4 or 5 new fentanyl analogs, which we hadn't seen before. So it's still an issue, but we're hopefully on the tail end of it. I do want to acknowledge my colleagues in Ohio, and especially Dr. John Wyman. He was the forensic toxicologist at the Cleveland Medical Examiner's Office. He provided so much information to me, and I appreciate his knowledge, and I consider him one of the foremost experts in Ohio on opioids. Some of these other people are my colleague. Steve Perch is the one that had to deal with the massive amount of carfentanil deaths in Akron. And also I wanted to acknowledge some of the people outside of Ohio that I was able to utilize their knowledge and expertise as well. I do have a slide with my contact information. However, I understand that if you have any questions, they will be sent to me through my email. And I want to thank you very much for letting me present to you today.
Thank you, Douglas, for that informative presentation. I would also like to thank LabRoots for making today's educational webcast possible. And as a final reminder, Mr. Rohde will follow up with any questions you've submitted via email. That's all for now. Thank you for joining us, and we hope to see you again soon. Goodbye.